All right, we're back with some statistics. We're going to look at a two-tailed t-test. For those of you that are following along in Mr. Walton's glorious packet, we're talking about packet page 16, number 3. All right, so let's read carefully. Since we're looking at this problem about a certain drug company and the amount of effective acetaminophen that they put in each of their drugs, and the fact that the FDA thinks something fishy is going on at the company, and that the drug company is making a false claim. Now, this is interesting. False claim. They randomly select, we test the claim. Nothing is given as, so as I was saying, this is a little different. We're going to have a two-tailed test. So the first thing I want to make sure to do is write appropriately my null and alternative hypotheses so that I don't get them incorrect. We have mean, so we're going to use mu, and we don't think that the company is doing this correctly, so we're going to put not equal to, and of course we're going to say 600 because that's what's indicated by the given information. All right, so I might want to have my summary stats underneath, and I might want to define my population and my parameter. Of course, what did I tell you is most important? That would be the parameter. So if we're looking at the population, it's all of the drug companies medicine, whatever kind of medicine we're talking about. And the parameter of interest here is the mean amount of acetaminophen per fluid ounce for our medicine or drug, whichever you prefer. So again, we're looking for the mean amount of acetaminophen per 1 fluid ounce, and then we're going to test this by using a two-tailed t-test. First of all, let's make sure we have all of our summary stats. We have our mean for the population, mu. We have the mean of the sample, which was gathered as 589 with a standard deviation of 21. We have a sample of 65, which means our degrees of freedom will be 64. From this, we can calculate the standard error as 21 over the square root of 65. I'm just going to leave it like that. And that allows me to calculate our test statistic T, which of course would be x bar minus mu over the standard error. In this case, that's going to be negative 4.223. We are not given an alpha level. Therefore, I'm going to pick the standard alpha level of 0.05. Once we have this set up, I'm hoping we realize the next step is conditions. For our conditions, we look at randomness, and it is given that the samples, so again, it's given that the samples of medicine are randomly selected for independence. This is a drug company, so I believe that it is reasonable to assume that the company produces more than 650 ounces of this medicine. Again, that's our 10% rule, so that's 10 times this 65. because we have 65 1-ounce samples, which means our 1-ounce samples should be independent. All right then. And lastly, for normality, since n is greater than or equal to 30, because n is equal to 65, the sampling distribution should be approximately normal. Now all my conditions have been met. I need to state all my conditions have been met. So I will continue and calculate a one sample significance test for means. Or if you want to call it a t-test, you're welcome to do so. And this is where we've got to remember to have our beautiful and lovely, again, that's our beautiful and lovely picture and probability statement. Now I'm going to make my picture first, because I'm hoping that it will help illustrate what I'm supposed to do. Of course, I'm going to do this in terms of the actual sample values. So we're saying 600 is the mean of the sampling distribution, because we're going to remember that mu of x bar is equal to mu. And we were given a sample mean of 589. So I'm going to shade to the left, but we have to remember this is a two-tailed test. So I'm also going to have to shade to the right. Please don't forget the difference between these two is 11. Therefore, I need another distance that is 11. So I'm going to make sure that I have this labeled as 611. So my probability statement would be that x bar is less than 589, or the probability that x bar is greater than 611, which we talked about, we could rewrite as 2 times the probability that x bar is less than 589. We calculate this appropriately by using our t-test. We should come up with a value of 7.77 times 10 to the negative fifth, which is approximately 0. Finally, what do we need to write? Our money statement. Oh yeah. Money statement says 3 parts. Since our p-value is less than, is less than our alpha level, right? Because I think 0 is less than 0.05, right? We reject H sub O. What does that mean? The claim here is based on the FDA, so the evidence supports the FDA's claim that the correct amount of acetaminophen, which is 600 milligrams, is not in the 1 fluid ounce of medicine. Or something fishy is going on.